Hello, my name is Cecil, and today I'm going to be walking you through a Physics 211 problem from Chapter 18 focusing on finding the equilibrium temperature. In this example, a steel beam at 120 degrees Celsius and a ceramic plate at 25 degrees Celsius are brought into contact in a vacuum. They then are left in contact until they reach thermal equilibrium. Given that the ceramic plate's specific heat is 1.1233 joules over Celsius times grams, and that it weighs 1.2 kilograms, as well as the fact that the steel beam has a specific heat of 0.449 joules over Celsius times grams and weighs 0.4 kilograms, find the equilibrium temperature. In order to solve this problem, what we're first going to need to do is we are going to write down what we already know from the problem, which is that the specific heat of the ceramic is equal to 1.123 joules over Celsius times grams, that the specific heat of the steel is equal to 0.449 joules over Celsius times grams, that the mass of the ceramic plate is equal to 1.2 kilograms or 1,200 grams, and that the mass of the steel beam is equal to 0.4 kilograms or 400 grams. Now, in order to solve it, another important thing that we need to distinguish from the problem itself is that it is in a vacuum, because another important thing we need to recognize is that this occurs within a vacuum. Why is this important? It's important because it means that there is no energy escaping through the air, because through contact with the air, the steel plate would lose energy. This means that energy is going to be conserved between just these two bodies. We can say that the negative energy of the steel is going to be equal to the energy of... Basically what this is saying is that the energy lost from the steel beam is going to be equal to the energy gained by the ceramic plate. In order to actually utilize this equation, what we're going to need to do is we're going to need to solve for both QS and QC. First, I'm going to solve for the thermal energy of the ceramic plate, and that's going to be equal to Cc times Mc times Tf minus Ti, where C is the specific heat, M is the mass, and T is the temperature. In this case, Cc is equal to 1.123 joules over Celsius times grams. M is equal to 1,200 grams. We don't know what Tf is, and Ti is 25 degrees Celsius. So Qc is going to be equal to, if we simplify, 1,347.6 joules over Celsius times Tf minus 25 degrees Celsius, or it'll be equal to 1,347.6 joules over Kelvin minus 33,690 joules. And now for the thermal energy of the steel, it's going to be equal to Cs times Ms times Tf minus Ti, or it's going to be equal to 0.449 joules over Celsius times grams, multiplied by 400 grams, multiplied by Tf minus 120 degrees Celsius, or Q of the steel is going to be equal to 179.6 joules over Celsius, multiplied by Tf minus 120 degrees Celsius, which if we simplify would be 179.6 joules over Kelvin plus 21,552 joules. And then we know that negative Qs is equal to Qc, negative 179.6 joules over Celsius plus 21,552 joules is equal to 1,347.6 joules over Kelvin Tf. I forgot a Tf here. minus 33,690 joules. Now all we need to do is solve for TF, which will be equal to 33,690 joules plus 21,552 joules over 1,527.2 joules over Celsius. You'll find the units of the joules cancel and the Celsius will come on top. And TF is equal to 36.17 degrees Celsius. So the temperature at which both will be at equilibrium is going to be 36.17 Celsius. So I hope this was helpful, and I will see you in the next one. Have a great day.